Hello everyone, welcome to our channel Everyday E-Learning. So in today's video of digital logic design, we are going to understand the concept of a decoder. So a decoder is able to detect the presence of a specified combination of bits or code given as input and indicate the presence of that code by a specified output. Now there are different kinds of decoders like 3 to 8 line decoders or 4 to 16 line decoders or even 5 to 32 line decoders. There are different decoders for different purposes. Now you might wonder what the numbers indicate. So 3 indicate the inputs, you can understand by seeing the figure 2, and 8 indicate the number of outputs. That is, a 3 to 8 line decoder is successfully able to convert the 3 given inputs and divide it into 8 separate outputs. This is the basic function of a decoder, to give us a specified output out of its given input sequence. Now you will be able to understand the concept of decoder or decoding sequence if I take one example. For instance, now if you see this one, we're asked to determine the decoding sequence of the binary number 1010 by producing a high level output. So before I move on to explanation of this example, I'd like to indicate here that if you are said a high level, you'll have to understand that the decoder consists of AND gates inside it, and whenever it is said low level, we'll understand that the decoder has NAND gates inside it. So this is very important to understand. Alright, so now let's move on to the example on the right side. So we are given the decoding sequence 1010. So if we give some names, this is A0 this is A1, this is again A2 and this is finally A3. So if we produce a decoding sequence for this A0, we have to produce for A0. Let's take a NOT gate. So we have this one, and then A1 is 1, we don't need a NOT gate, and then we have A2 which is 0, so we need an inverter again to convert it to 1, and finally we have A3. So since we are set to use active high, so we will use an AND gate to attach all the input lines. So we'll have, for all high inputs, the output is equals to 1. Therefore the output we generated from all these 4 input sequence is equals to 1. So as we can see here, that if we are given a sequence of inputs, we can shorten the input, or we can indicate the presence of high bit input using only a single bit with the help of a decoder. Now we can also do this with the help of active low output. So in that case, we'll have to use the NAND operation. Now I'll not show the NAND operation with the sequence given here, but I'll show the 3 to 8 line decoder table taking the NAND operation. So I have taken here the table required to design a 3 to 8 line active low decoder. So if you remember, the active low decoder is the one which is made with the help of NAND gates. So as this is a 3 to 8 line decoder, we'll be able to have 8 output bits, which is 0 to 7. There are 8 outputs, and we will give 3 inputs, and those are A2, A1 and A0. So the sequence will go on from 000 to 111, which is from 0 to 7 in binary, and for 000 the decoder will give us the output sequence of 0. So in this case, the output pin of 0 number, that is D0 output pin, will be active. Since we used NAND gate here, the output will be indicated with the help of 0 or a false value. So as you can see here, The input sequence is A2 naught, A1 naught, and A0 naught, whole naught. Whole naught indicates the NAND gate. NAND is used here. So in this manner, if you go on, you will be able to see that as the binary input sequence changes, the decoder is giving different values for the output lines. So whenever we select binary 1, the decoder pin number 1 is activated. And again, whenever we select the binary sequence 2, which is 010, then the decoder actives its D2 number pin. So you see the output pins from D0 to D7 are shown here. In this way, as we change the binary input bits that you can see on this table, the output pins of the decoder will be simultaneously activated. So in this manner, whenever we select the input bits 111, then the output pin of the decoder D7 is activated. So I'm repeating again, as this is active low, the activated one is indicated with output 0. Now this is the decoder function or decoding function for developing this decoder. If you would like to implement the function, then you will be able to develop this 3 to 8 line decoder. Now you can use any kind of simulation software to create this function, and you will be able to develop a 3 to 8 line decoder as a result. So in this pattern, using active high or active low, that is NAND or AND gates, you will be able to develop different kinds of decoder like 4 to 16 or 5 to 32. All you need to do is at first make the chart like this, and then it will be very easy for you to develop the decoder. So I hope it is clear to you about the concept of a decoder. If you have any question, feel free to write down below, and thank you for watching our video.